Hello. Okay, it works. Okay, welcome everyone. I am Navdeep. I am joined with my co-founder Mayur, the other co-founder sitting in Pune. Uh, Hope we are not ruining your Fridays. So we'll be focusing on mostly on like why did we choose Rust and how it's relevant and more relevant uh, in the cloud code and for that matter. We'll be focusing on various basics like to give you the encouragement to pick Rust and why the Rust makes sense in the system programming or for that matter extra programming and all. Um, so shall we start? Okay, cool. So to give a background and to give an encouragement to everyone who's available here. So we are part of OrcaSheets. So OrcaSheets is built out of purely on Rust, and we'll show the why we chose Rust actually. So, okay, uh, we, hi. Do we have a okay, cool. So we'll show that power of Rust actually right now. So let me. I think I'm sharing my screen too. So I'll be loading the largest file that I might have. Okay, so let's see. So this is around 12 GB, around 20 million rows, and all loaded. All my applications are running, like even like my multiple Chrome tabs, multiple IntelliJ, multiple Cloud Code, or for that matter everything. And I'll still keep on loading as much as data that I want. I load 20 million. That I load another 20 million. Load that. So I have currently loaded around 100 million of rows in front of you in hardly a blink of a second. And all no load. My laptop is not burning, is not on flame. You can't even actually consider this to be loading such amount of data. So you can't even actually load any amount of. There is no desktop application or for that matter locally that you can show and load such amount of data. So that's the power of Rust. And why it becomes more relevant when we are actually shipping our code, which is running on your desktop itself, is because like we can't afford the crashing, those null pointer exceptions, those type exceptions that you actually fix on 2 a.m., 3 a.m. on your server code. So it becomes more relevant when you're actually building a code which is to be run in a browser or in for that matter on others' laptops, which you can't fix on a daily basis, on an hourly basis. So Rust brings that. It actually at a compile time or at the time of building it ensures you that it's it's foolproof. If it compiles, it works. So based on that, we will be starting like 5 exercises. It's a very short workshop. Hopefully, we should be able to complete in 90 minutes, and you can go back. And and we'll be starting with very simple type systems. Then we'll be looking at how we are utilizing some of the very basic nuances of Rust in OrcaSheets, which is actually helped us in like, currently OrcaSheet is running on more than 10,000 different laptops around the world, and we are still not seeing any crashes or any fixes. It's just the feature request that we actually come up with it. Not even a single time for the past 2 years we have seen that someone has said it's crashed. It's not working. It's a like my it takes time to load the data. No, people are asking that can we do more around it? Can we bring in more AI? Can we bring in? There has always been a feature request rather than the bugs request. So coming again back to the setup of the workshop. So So I think hope everyone has actually set up the Rust on your laptops. Okay, so can you like just run a Rust C hyphen hyphen version at your laptop and see like if it's working? Okay. Uh, so I'll be sharing. We have shared a GitHub repo link. Uh, if everyone has actually shared that, so we'll be walking through these exercises. Solution is also included. It's not an exam or something like that. You all have 100 marks already from the starting of the exercises. So, hope like it'll have everyone actually clone the repo. I'll share the repo later. Okay, uh, I'll be using Rust Rover. Hopefully, like people are using VS Code or a Paint Concept. The exercises are self-sufficient itself. They are not using any external library. So we'll start like if everyone can actually say here like yeah, repo link we have shared in the in the Zoom chat. Yeah, this is better. Has everyone cloned? Yeah. It's not. Yeah, it will not build. Yeah, no, that's fine. That's fine. Yeah, that's fine. That's fine. Yeah. Switching. Okay. Okay.
But he have this
Okay. You were able to clone it. Yeah. So you are using. Okay. Okay. Um, so uh, all the exercises are actually available in the exercise folder. Um, since I will be using Rust Rover, but if you are actually pure command line, pure geek, then you have always, we have given the commands to compile that particular binary itself. Each binary can be built and compiled separately with the commands and running exercises in our README. So all you have to run, if we are actually on exercise 1, you can always run cargo bin exercise 01 types. These are all defined in our cargo toml. This is more like your requirement.txt, your pom.xmls of the word. So we have defined a separate bin for each exercise itself. All done? Okay, cool. So the intention of the, or the encouragement for the first exercise is, say I have a function which takes 2 integers, 2 strings, or any 2 types. And we actually, like say for example, get order details, which actually fetches customer ID and order ID. So a lot of time, that specifically for me itself, that we have seen that sometimes we swap it. Like we are passing order ID to customer ID and customer ID to order ID for that matter. So these are some of the very small nuances. Like normally a coder wouldn't actually be, this might be happening, but by a mistake, what we are actually trying to enforce here is, like, if we are building, if we are giving a framework to anyone, or someone else is actually going to work on your framework or build something upon it, you can enforce them to actually not make mistakes. That's where the SDKs and all, like, yeah. So currently, most of the current SDKs are actually being built in Rust. You can see actually mostly the CLIs that are actually coming up are being built mostly in Rust. And Word is moving towards building basic functionalities of system programming in Rust. So today we'll see, like, how we make a mistake when we swap the integers or the parameters that are being passed, and how we can enforce, or we can avoid that in Rust very easily at a compile time. So so the first, I'll share this. So the first part is, if we can actually try to use the match. Match is very similar to case, and try to find customer. Like we have defined a simple example of find customer. Let's try to compile this by calling the first to do. So I think this will be a good exercise to actually match or see if the Rust is compiling or not, or you are able to run it or not. Just uncomment the match result. So clearly here it will see that like this is the very starting um, uh, of the exercises. So here itself, like if I actually do it via compile time, let's see. Oh. Yeah, yeah, yeah. Yeah. So it clearly tells me that if I actually like want to pass the something that like if a find customer is being provided to me, then it's a responsibility of me to handle the null cases itself. So uh, so I just can't expect the string to be returned. So I need to handle in a way that if a null is coming to me, that I need to handle it. Now the find customer might be given by the framework itself. I need to take care of it. If a null comes, then I have to handle the null part of it. So that's the good part. We are enforcing down for anyone who is actually using it to actually handle the null case. So this is not compiling. We'll comment it. We'll see. Yeah. So it does. So were everyone able to found Alice and got Bob? Okay, cool. Uh, so this is where like it's become important. Like everywhere in the Rust itself, you will always found the option being returned, result being given, being returned itself. So when you are actually using any of the library, you will be enforced to actually. We will cover the result part also later. But this is how you enforce anyone to the user that they should be handling the null cases. What would actually happen in case of this is the classic case of when we started the exercises, like you get a 2 a.m. Null pointer exception because I don't know that what can actually come up. If the customer is not present, if I pass say 9,000 and it actually comes as none, then I didn't know I might not have actually handled it. Okay, so a good programmer would, but normally I would get an exception of say null pointer exception if I'm doing anything upon it. So this is how Rust enforces you to use better constructs. Now, if everyone has got it, let's move on to the to do 4. Just uncomment it, and this is where you can override the part very similar to the try exception. For that matter, if a null comes anything if else, then you can always return what is what else that you can actually return to back. So again, you are handling a null and you are overriding uh, with your own return type. So I'll again run this. I got an unknown too. Okay. Okay, I hope everyone is able to complete a to-do. Now to-do 5 is something that will let you actually work out. Will be like a string is passed actually, and please use to get a first character of it. And if even if the empty string is passed, or for that matter, uh, a full string, a larger string is passed, how you would actually return a first character. You can always use next on the to iter upon the string. So if you can actually come up, there is always a solution in the solution exercise. If you want to refer it, you can always refer it, but try to compile with respect to string. The intention of using next is how Rust is actually like, since this is a construct that has been enforced to us, so it will always return you an option. So these standard libraries are always giving you an option of option actually. Yeah, so like you will always get a option as returned. So that way you are always handling the part of none. Any issues? Like, we'll give us some time for the first care. Yeah. Huh. Yeah. Yeah.
Is it in regular programming when we are developing some
Yeah.
application middleware or something
Mm.
like that?
Mm.
So is it like use option whenever it's possible, or is it there is a constraint to use option? Then this
Mm.
kind of thing will come with that option,
Mm.
and then you have a limitation, or you will have a burden of that thing. So if you are using option,
Yeah.
then be mindful when you are using.
So it's the more the bigger motive it is, like if you are building for someone and if you actually returning a function that someone might actually use it, okay, and you also don't know that sometimes I'll return a none or sometimes I'll return some value. So in case of how would you enforce to a caller that you need to handle this if a none comes? In case of Java, in case of Python, you don't actually have a way, right? Or you have a way, you build a construct upon it. So, so which actually tells you nullability. Okay. So if you want to enforce the caller that you have to handle null scenario, I can send, like if a customer, there is no order ID, then you need to handle it. That way you design functions such like that, that the onus is actually on to the person to handle that. So it's not a burden per se, but more of a good practice. Like if I would have been doing that in say in Java or in Python for that matter, I would have created a construct which has also is nullable, or for that matter, it's allowing you to check the nullability of it. Otherwise, everyone, if you, the onus is on the good programmer, okay? Like if you are a good programmer, then I'll check is not equal to null. There is always a function, always a construct in the above that you always check is not equal to null, this object is not equal to null. So option enforces you, otherwise it will not compile. But in Java and other places, you can always build and you will always see a null pointer exception, and then you fix it. Okay, here this is being enforced to you. Huh. Yeah, yeah, absolutely. There is no, so you can always abuse the language. Like we'll see like way, if you put a dot unwrap on most of the things like on result, on option, there is always a chance that that might fail. Okay. Yeah. Yeah. Hi. Okay, so there is a question that when we should unwrap or unwraps or else. So, so I think there is more a syntactic sugar where you can use it interchangeably or else and but or else actually gives you a function that you can actually define that in case of else. But these are more syntactic sugar. Feel free to use any of it interchangeably. Yeah. You can sit. You can sit.
So one question is that.
Yeah.
So generally, two ways of writing the code, right? So one is like just as a POC, or you are trying to achieve something, and one is the production level.
Yeah.
Right. So POC people can just write unwrap or question mark, right? But I don't want to push that thing if any developer is creating a PR. So is there any way we can detect and just kind of
Detect.
if people are doing that kind of practice, like without handling or just putting question mark or unwrap, in the pipeline only we
Acha.
can.
So you are saying that is there a way to see that that the code is being abused, like everyone is using dot unwrap everywhere. So like I think there is a more of a practice. I think there is a tools like sync and all which actually tells you that so it tells you that it might fail here. There is always a warning that will come up. We can actually see in the compiler itself that this is a part where you haven't handled the null. So compiler will give you warnings also that you need to handle this. In my code itself, in OrcaSheet itself, there is hundreds of such warnings that actually come that you have unwrapped it. So the warning will always be coming by the compiler.
Is there any way or mode in the compiler level so that we can set it up while maybe writing a CI pipeline so it will never allow? So is there
Absolutely, absolutely. You can actually have a Git commits or Git hooks also, where that you want what level of severity level of warning that you want to allow. In the IDs itself, we have said that. In our company itself, we have set it at the Git commit hooks itself. So we don't allow like even like certain warnings also to be pushed into the production.
There's something like an empty string in that EDR empty strings, like
Yeah.
but like there is a null byte in C. Is there also a character equivalent of a null character?
So there are multiple wrappers. Like string new is an empty string actually, but the good thing about the Rust is like when you define an empty string and it's you see that it's not being used, so it will at a compile time it will remove that. So for example, even if I make a mistake here and I'm not using it, I'll show that. So this is just compiling. Like I have not actually done that because no one is actually using it anyway. Yeah. So that's the beauty of the compiler itself, that when you say empty string or something like that, you have defined it, you're not using it, it won't matter to it. It would actually give a warning that you're not using this code, you can remove it. But there is many patterns of empty string itself, like string new, or you can always create a quote, single quote. You can all.
The compiled program line number 56 doesn't
Yes, it doesn't exist. It doesn't exist. So even if I do it, say, um, first character or say none, none it won't accept. Some, none. So this will actually fail otherwise, but it doesn't exist in option 3. It just compiles very well. Okay, so are we able to complete the first char, everyone? MJ? Okay, cool. So I think the intention of the call is like, I think the very good question have been asked, like how, like, is it an enforcement? Is it how you need to take care at a compile time? So none is being enforced to you. When you are building, tomorrow if you go and start building something, some SDKs, you know, for that matter, I need to enforce my consumer of these codes to handle it. So this was the learning of the exercise one. Yeah, please, please.
So the two test cases that we have here, test it with a non-empty string and test it with an empty string. So when it's the non-empty string, in order to print whatever that string is, let's say I unwrap it. Because you have told me that the function signature is fixed.
Yeah.
Now, when the empty string is passed, I have to do an unwrap or maybe I choose to do an unwrap so that I can print some character which denotes that this is an empty string.
Yeah.
Now, what that means is that after calling the function, I am still taking a decision as to how to unwrap the result.
Yeah.
Instead of that, can we not just remove the option part entirely from the? So, what is a better practice in this case?
No, absolutely. Like, say, suppose you are a SDK builder. Okay. Now you actually give an option of people to fetch the status of the order. Okay. How would you like? And it actually gives you you pass something very arbitrary order ID and something like. How would you want to actually handle that? So like I can give anything for that matter, but you want to enforce to the users. Like I'm asking you, like how would you define in a Java word or a Python word that or enforce my user to handle nulls?
So, like even a simpler example, if you are returning a string directly without option, and the consumer is doing some operation on the string directly. I see. Yeah. So there's no way I can have a fallback string for everything.
Yeah. Or you can have a trust on the programmer. Yeah.
Let it crash and catch the exception.
Yeah, so that is a fallback. That's a reactive programming actually. Rather than being a proactive programming, you know that this is the confidence that we have when we are shipping OrcaSheets. It's a 50 MB binary. If anyone wants to use our SDK itself, or we know for that matter, it will never fail because these are the certain things that he have to handle it. And if he's handling it, then it will not crash.
So how do you tell the user that they need to do something different?
Return type. So if I'm returning option, he has to do some. He has to do dot unwrap or something like that. Yeah. Okay, cool. I think this is extremely productive. So this is again the second, like I think it's more important, the second exercise is more important than the first one. This is the result type, and this is the most ubiquitous return type everywhere that you will get in Rust. And I think I would say like 99% of the cases you will see the result being written or you are returning result. Now, why do we need result? For example, up till now I have written an option for nullability. If the data could be null or it could be present or not. But what if I want to return an error? Like if someone is asking me what's the status of the order ID,
I want to send that my servers are down or for the payment gateway is down. Okay, so I need to return an error. Okay, this is very similar to throws in Java, or for that matter, it's similar to exception handling that you would actually see in the Pythons of the world. So the result is in itself an enum. Okay, enums are very interesting in Rust. They are heterogeneous. In Java, in other words, it's always the same type of enums you have to define. It's if an integer, then it has to be all the values have to be integer. But in Rust, you can have an enum with multiple heterogeneous types. So inherently, result is an enum where the first part is actually a success and second is an error type. You can define your own error type, but there is a standard error that you can return. So if I want to say write a function where I want to communicate an error back to the user that that payment gateway is down, or anyone, or my boss is calling me or something like that. So you need to handle that error. Now we are coming from option to result because there are more constructs, or more, like, it's not about always about nullability of the data, but more about how is the I want to communicate an error. So so this is like we'll be focusing on a parse positive, where a parse function, it takes a string and it returns an integer, and we'll be seeing like how we can communicate our error itself. So the first exercise is so we'll skip the to do of custom error type for now. We'll directly go to the to do of first thing. Just uncomment this and run it. If we are able to complete it. Are we able to? So like if most people are able to compile for and get the result of 42, we'll make a small change in the parse where we would add a very big number, like say I want to say it's a very big number. So वही कर रहा हूँ. So just add any of your liking of the number. We'll then switch to defining your own parse error itself. So this is way of yeah. Yeah. Yeah, yeah.
When you explain the code, right, just simply say what is okay, what is this, so I
Oh, absolutely, absolutely. Ha, ha, ha. I think this makes sense. I'll do that. Okay, cool. So, so the match is very similar to the case statement, and the result of this is actually the case statements. This is the syntax of Rust itself. So it's returning okay. It's again a optional type that it returns an okay or an error, and upon that we are defining n. So it's a self-referencing way of, like in, I don't know, like in closure and all, when we unparse it, like if a function is returning a tuple in Python and you say 1, 2, so it dereferencing itself, and then you can start using. So similarly, n can be used later on. It's a single line reference syntax of writing a function. You can always change this function by using the like defining a function like this in a curly braces. So it's a syntactic sugar itself to write a single line function. So and that's why I think in the exercise itself it's more of like uncomment and comment that we have ensured to make it work. Any question that you might have with respect to syntax?
So if the number that we want to pass itself is bigger than 64 bits, will the error still be called this error in line number 37?
Yes, yes, yes. So if it's greater than, let's see that. I don't know, like E64 is quite a big number actually, but we can change it. We can change it to E8, I8. Sorry. So this is the compile time error that you are actually getting.
Let's say not a
Yeah. So it's a compile time exception that you are actually getting.
So actually, for me it worked that. Oh, okay, you have changed it to 8.
I8. Yeah.
I understand it. Now, if somebody has write the SDK and I use that library, okay. So in my even my code, the compiler will show that particular library is handled only the 64-bit of code.
Yeah. Yeah.
Now, when I build this service, microservice, and that time on the client side I send the solution of the huge number to work with that.
Okay. So let's consider.
Not come under the compiler case. That is a runtime case.
Yeah. Yeah. Yeah.
Change from the compiler time to runtime.
Yeah.
So,
Yeah. So like let's consider the part of REST APIs. Okay. In REST API you pass extremely big number. Okay. Then it's very easy to define if we are working with a frameworks like Actix and all, like which enables you to write REST APIs in Rust. Okay. All you have to define in the construct itself that these are the types that I accept. Okay. And the error is automatically taken care by the caller as 401s. It's a bad request. So that way, like you have defined a construct in Rust, like I accept a structure of, say, like I define a struct. First is age, and I define this as U8, and I define request. Now, if you even pass a larger number, if you pass a larger number here, it's there itself it will return the error, right? So you are getting like it's a dynamic type might come up from the outside of the word, right? But you don't need to handle like if it is greater than that, or if you have to parse it. You are enforcing the exception or the acceptance of the data there itself. But these are the constructs are very well established in the other languages also, like when you accept a say you define a struct in Java, you define a struct or type system in Python, and you pass a larger number, there itself it checks that. Okay, but here itself there is no cost. When you actually define, you don't need to define that parse and checking that it's greater than or not, but there itself will return the error, and that error is being returned to the user itself that you need to handle. This is a result type. He might be receiving the result type where he needs to handle the error. So this is what we are actually focused on, right? So he will receive an error, a result he will check is error, and then it will move on. So that's how we are enforcing that that error or any malicious data that is being sent is being handled. Yeah, 1 second. Huh. Yeah. Huh. Mm. Mm. Huh. 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 Yeah. Exactly. So like I think I forgot to mention in the first part exercise itself, we call it zero cost abstractions in Rust. So when you are defining a struct in Java or in, for that matter, in other languages, there is always a things got added in heap, like it's allocated in a heap. But here when you define a single struct of say U8, so in compiler itself, it's actually taking the size of U8 only. There is no additional of, so that's the optimization that your Rust compiler does. So it actually allocates only what it's being contained rather than it doesn't have a baggage of itself. So that's the cost, we call it zero cost. We'll also cover that part also in a further exercise also, where we'll see that with defining a simple phantom data, you are mentioning that this will contain only this type of data. So that otherwise in other languages that cost you a extra baggage of struct. So in hindsight in Python it contains at least 10 different metadata when you define a class or when you define a struct. Here it's very easy and it's a zero cost, and it's very relevant to us also, because if we would have developed the same desktop application or a big data application in Java or something like that, and we define a class, then so much million garbage collection will be happening. But here it's a zero cost abstraction. Yeah.
I have a question from online.
Yeah, it
Am
doesn't
I
use
audible?
that memory.
Can I ask?
Yeah. So it's a in Java and all, these were run because it has defined those blocks in which the heap will be allocated. But apparently here it's a like, I might not be able to answer exactly why there is no requirement of padding here, but the cost allocation is equivalent to what we actually define here. Yeah. Yeah. Hmm. 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 Okay, yeah, so there is no implicit casting. We'll see somewhere where there can be a casting can be done. Like for example, I need to cast a larger number into a smaller number, say int64 to U8, the reverse one actually, U8 to int64. So that can happen in let, like I define something like this, let um, I can define a larger number, a smaller number here, say 10. So by default, this 19 will be a U8, but you can always define, like give a hint to the compiler that I want to make it as U64, because later on I might be doing some operation that it make it a big. So this is a type of conversion that you can do at the compile time itself, but there is no implicit conversion that is happening. Okay, so moving on with respect to parse error. If we can just see like
Hello? There are questions from online. Somebody is able to hear us? Hello, question from online Zoom.
Maybe
Okay.
they might have
okay, we'll define
muted.
now an error quickly. Say just uncomment this parse error
I think
and
there's no
add your
point in muting, right?
any other error. This is extremely important because when you're creating a framework, when you are starting thing from scratch, you always want to define your own exceptions. You want to always define your own errors because like in the end, like there is always a list. You should have a big enum list, which is uniform in your whole framework, which can define all your error types. So define your own error parsing. I'll define one parsing error. Say I don't like this number. And here you define what type or what string that you need to mention. Like suppose here I want to define, like in error itself, I want to give a message. So you define here a string, okay. And here I can again say this. I have defined my own error type. So like just define your own error type and try to return that from the error itself. This will give like more of a like a hands-on on how to define your own error and return it. Yeah, please.
Why do you have string as an error type?
Oh, okay. No, that's fine. Like for example, I can define this as a number also. Okay. Like for example, yes. So like parse error. I don't like this number, like that. So you can. So that's how you return your own type. Say parse error. I don't like this number. Now you define the message that you want to communicate to it. Or if you can actually say exchange number, like say I define another number, say which says so it's upon you to what error and how you want to represent it. So I can here like say parse exception.
So all the return, the error type should also be same in that case.
Yeah, error type needs to be changed. Yeah. So here we define parse exception, and I need to change everything now. So yeah. Sorry. Yeah, yeah, yeah. I didn't get you. Sorry.
I think you can use toString and just convert that enum into your string and just return this.
That's your way of handling of error. Like you get an error, you got dot toString, and you can fetch what's there in it. But you will always know from the return type that what kind of a error this could be. You need to write say error and match different kind of error. What I need to do it for every error type. So then you have to define a case match, that because this can return me a parse error, and parse error are these 5 types. I need to handle each one of them. You have to are enforcing to the caller that You need to handle each. I can send any of these error to you. Huh. Yeah.
Multiple domain error,
Yeah.
coming from network or coming from some data somewhere else. In that case, what should be a best way to return that
Yeah.
kind of error?
Yeah, very well. So that's why you need to define your own error types. Okay, define your own exhaustive error types. Keep building slowly what different kind of errors. There is always a chance, always a way that you just parse what you are getting and return that itself. But that if someone is using your SDK itself, then he needs to handle so many different things. He need to import those errors. Okay, so it's good exercises that you bring a uniformity for the user itself. That I need to only take care of like say your company name is XYZ, so XYZ error. Then I have only one file that actually handles all these kind of errors itself. So it's a good practice, a good exercise to handle. Define your own errors when you're defining your own SDK or any caller. But anyways, there are always standard errors that you can set that you don't need to import. But it's a very good. We have learned it a hard way that we need to define our own errors. Yeah. Yes. Yes. Okay, I'll also mention about these traits that you can define. So I got an error of this, like parse error cannot be formatted because they're default formatter. So in Rust, we have traits that you can decorate, very similar to decorators. It tells that for that enum or a struct, you need to implement these traits will be included in it. So for example, I say debug, then anyone wants to use this struct as a debugger can use it. Say in other structs we will see that the serializer, it should be serializable, it should have a partial equivalent, then it supports equal to. So very similar to when we define extend a string, then string has multiple functions defined in it. So that way when you implements or accepts in Java, similar to that, like the compiler will include those functionalities for you for that struct itself. So if I add say clone, then you will be able to clone it. That's how you can actually define that what the user can actually also do with that object itself. So I have defined debug on it, and then I do it run parser. ठीक है. So, if we have done the error part, we'll see the result type. We'll define a more result type. Let's move on to add to. Let's uncomment the add to part, and we can see okay. Now we'll come on to the part of question mark. Again, this is a kind of a short circuit on error. It's very similar to throws. Like it enforces you to that if there is a value in it, you return that value. Otherwise, it will return an error. So in Java, you would have actually done the try exception. In Go, you would have written a 5 language if dot error is not equal to null, the value is not equal to null. So it's a very shortcut of way of handling the return type of parse positive. So it actually tells you that. Otherwise, I would have done that instead of question mark. I would have handled it that dot result. I would have captured this as so result parse exception, and then I would have see if x dot is error. If x dot is error. So it's a shortcut to actually handle this. So if you want to handle anything, and the question mark will actually be enable you to just throw from that or return from that instant itself where the error might come up from that function itself. So it returns the value. If there is actual value, no failure. Otherwise, it throws it. The caller have to handle it. So it throws from that function itself. So the function itself have to return the result for that. No. Yeah. So wherever that you want to handle that exception, okay, you can then unparse it and see the error itself. Now, suppose an error is coming on to me something from an SDK, which I don't want to handle it. I just want to throw it up, like I want to bubble it up to the UI or for that matter. So that way you keep throwing till the top, and then the caller will receive the function, and then he need to handle that. Yeah, throw is it. Yeah, very similar to Java throws. No, it will not change that. So, yeah. Yes, absolutely. You have to change this. You have to change this through parse exception, parse error. But apparently, yeah, you have to change that. So again, the same thing that you have asked, like you have to redefine the parse positive to return the parse error itself. So the 2 to 5 is about actually return your own parse errors, and you can just populate it back it. Output.
वो नीचे है ना उसको
ये
ये नीचे का जो आउटपुट एरर दिख रहा है ना वो नहीं दिख रहा है
अच्छा ओ हाँ this one. So these are the functions that are being called parse positive. Yeah. So these are the outputs of this one. So what we are seeing right now is like these are the like error, I don't like this number, then okay 30. So these are being written for this part. I see that these are not being called at all because I am not using them. If I actually assign it and then try to print it, then these will actually be getting realized. Currently, compiler is saying that you are not using anywhere and what's the output of it, so it will not, it's not doing anything. And these are the two output of the println of add2 itself. So it returns me an error, so not a number, BA, and that's how we are actually getting it. So the question mark helps you define the what's the struct of the return type. Okay, otherwise you can always do this thing and then it has to like be a string or a printable or that's why, but with question mark it lets you know what's there, the syntactic is like what's the return type to actually get your more debuggable prints. Acha. Hmm. Huh. Line number 31. Yeah, this one. Huh. Nah, so this is a struct where result type will be the first value of it will be the value it returned will be our I64. So the parse error is a type of the error. Huh. Huh. Return type, oh, error type. It's a error is of string type. Fails. Huh. Yeah. So, yeah.
Can I also add the correct case in the enum itself and say that now it's not a parse result, it's a parse error, it's a parse result. So even the correct case I want to return through just that.
Here.
In the enum.
You can define a number. You can define a number.
How does my function signature change? I mean, I can eliminate that I64 from there. And will it be just a result of that parse result?
You can remove. You want to remove this?
Yeah. So basically, you want a custom type as a result.
Custom type as a result type. You can override the result. Yeah. You can define your own result types. but it's I think have very seldomly seen people overriding a writing their own result type, because it's a construct which defines the value and error, which gives you a power to define what's being returned. So here in the first one you can define any struct, any class, anything, and the second part you can define any error. So it's a collection of value and error. So hardly I have seen people using that pattern of defining their own result type.
To having the correct result type known upfront over here.
Huh.
And what if like the function returns more than one error, can return more than one error? So how do you define that? Because right now it's a parse error
Yeah.
struct that
Yeah.
you define.
Yeah.
But let's say there are more than one error that can return.
So these are the different errors, no? Look, it's
So you just define
yeah. You define a construct, and
combination
yes,
of errors
yes.
can be defined within it.
Yeah. So e-commerce error. Now e-commerce error contain hundreds of different types of errors.
Let's suppose you have multiple layers of application or the system.
Hmm.
You don't want to populate that error to the user. You want to change at the mid level. In that case, how we can
You can capture the error itself. Say I'll define parse exception. I'll remove this. Okay, now it gives me both result. So if is x dot is error, I can define another error return type. So I'm changing it. Suppose it could be anything, but I define my own exception. Say I define my own error. And you can define anything in it. So you are overriding that and returning your own return type. So that way you can change my own error. So you have overridden like whatever parse exception that I might be getting, but I won't be returning that. I will be returning my error. So that's how you define. You catch those exception, you catch those error and return your own error type. Yeah. Okay, cool. So I think with respect to this, I think we will complete the result type. I think the result is most ubiquitous struct that you will ever see in Rust. And like if we are able to complete all the to-dos, this will give you a good hands-on type of how to handle result. You will see result, and like when I was starting Rust itself, I was also a bit apprehensive that why I need to actually return a result type later on. I can only return a string, I can only return a number, but then later on it struck that your consumer will also need to handle that. Otherwise, if I need to return an error, if something bad goes happen, then you need to be conscious of that. Yeah, that's a struct of the function. Struct of the function. Yeah. So you have to define the return type. It's a strongly typed language. Yeah. Sorry, I couldn't get. Yeah. Huh. References. Yeah. So in result itself, you can have a references being returned. So for example, I can say colon str like this. So this is how you return a references. But that's another topic that we might to discuss, the borrower pattern or the time, the range, the time, the living time of that particular object. So has to be within available. Like if I'm returning a references to it, anyone who is using it has to have be available within the same time range or the livability of that particular object. So like if I have defined a str over here and I am passing the reference to it, then anyone using it has to be in the same construct itself. So that's how it doesn't do a garbage collection later on when you're passing a reference. The borrower has to be mindful of that, how long it will be living.
Recently on issue from like flight booking, double screen game, and they told because of non-pointer exception, like failure, I mean, how that kind of things.
Achha, you are asking that if I am passing a reference and that it's not available anymore. So that is what actually the beauty of Rust is. It actually compiles you that whenever that might be getting used, it might not be available. So it will give you an error of that this trait itself might not live enough. So yeah.
I mean, when we compile any application itself, we come to know.
Yeah. 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 Yeah.
Runtime.
Yeah, yeah. Even the race condition of your threads that might come up, Rust actually tells you at the compile time. So it knows for that matter that when, till when, from when to till when this object will be alive, and you have to use that object in between that time time scenario. So otherwise, if you are actually using beyond that, it will give you a compile time error. Okay. Okay, cool. So are we good to move to a new types? It's an interesting type also. Okay. So what we actually learned is the custom error type, custom the question mark operator, which actually it's a shortcut to actually handling of errors. Result type, which is extremely common, and we are good to go now to advance a bit of more advanced topics right now. This this enables you to write more advanced constructs in the Rust itself. So with new type, okay. So this is the same thing that I was talking about, like because I mentioned this error, like because we faced this very recently, where our order ID and a customer ID was interchangeably changed, and then after 3 weeks itself, we got to determine that when we are summing an order ID, it's coming out to be a few $1 trillion, because the order ID was starting from 10,000, and later on we checked that the value and order ID were getting replaced. So, and this is where I want to also, this is with respect to new types, the zero cost abstraction, where if you define a new type which contains a single integer, in other languages it will be allocating a space on your heap. It will be a huge garbage collection, but here it's a free zero cost abstraction that is given to you with the type security at compile time. So we will define the to do is like we will define our own struct type which contains only one value, the integer. So can we uncomment the part of from line number 17 to 18? So it only contains only one number, customer ID, and again I'll define the derive part, like it lets you have debug trait implemented for it. You can call the question mark colon on print. Clone is very important because in borrower pattern, if you are passing a struct to a function, then that function becomes the owner of that particular object. No one else down the line can actually use it. So you need to pass the clone of it to further use down. Copy is something like, again, make a copy, partial equivalent, you can use equal to sign. So these traits lets you define that these functions can be called upon it. Now just change this to accept the instead of U64, use customer ID. Look for lookup customer. Okay. So it's a struct. You can always access the struct from starting from a 0 index, 01.02, and you can also access by a name itself also. But here we have defined only one value, so we'll be accessing it by 0. Define a new order ID also. It can be on line number 19. I have defined a new order ID. Huh? Huh. 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 Will get the value without knowing. No, I didn't get without cloning. Yeah. So I think when you are passing, if the it cannot be used like it's being consumed by that function itself, then the pattern actually go.
If it is a value like U64 or something, does it consume?
It consumed fully. Yeah. And then here. Also, like let's define our new type also, column name. We'll define a result type here. So we are defining a new, we can, with respect to functions, when you define a class, there are member functions, okay? So member function are very specifically defined for that particular class itself. Here in Rust, you can define function also in this way, like implement column name, and you can define all the function that you need to implement for that particular struct type. Very similar to the function that you define in class. So when you initialize or create a new function, you can always use new. If I want to add any other functions, then that's how you define what function can run on that particular type itself. Okay, we have defined a function to create a new column name. If it's empty, then it will return an error. If it contains other than alphanumeric name, then it will return an error. Otherwise, it will return a column name itself from the name string itself. So again, it contains only a one name, one variable itself, member variable, which is string, pure string. So it's I think the same question that you also asked, like if we can actually define, if we are creating a new type and we want to define whenever we are initializing it, the error should come up. So here itself you can actually are defining when you're creating the value of it, if you're passing an empty string or something, at compile time it actually checks that. So one of the good pattern here is, like for example, if I have defined, if I am getting a column name itself, then I know for that matter, for the conformity, that it will not be an empty, it will not be an alphanumeric. I don't need to check it once I am consuming it anywhere else. So that way you don't need to do the same parsing logic, is empty or not. So you always know that for that matter that column name is valid. Okay. So like you can always copy it, like maybe like there is a more syntax to the Rust. You can copy from the solution also, the column name implementation, but we'll see like how it is actually responding to different call type. Now you see for that matter that, okay, I'll wait here. Which one?
Column name, string itself, field 0 is never used.
Field 0 is never used. Okay. Have you defined this function itself like this? Okay, let's see. No, but we will use it, because you might not be using it, that's why it's giving it, like down the line if you want, use it. So that's the compile, again same thing. If it, like you have defined the code but you are not using it anywhere on your code itself, it will say that it's never getting used. So it's a give up warning that you can remove it. Once you add a uncomment this part itself of using that struct itself, it will remove that warning.
But I want to use the struct because obviously there is
Ah,
a constructor there.
yeah. But you are still have not used it.
No, I mean, the test around was passing.
Okay.
So I'm certainly using the new function.
Okay, let's see.
Actually, in the println lines, we print good.0, bad.0 or something like that.
Yeah. क्या कर रहे हो?
आप zero access कर रहे हो ना, column name return कर रहा है.
हाँ.
It is returning 7. आपको access करना है. Column name जो नीचे है. यहाँ पे error है.
कहाँ है?
Error जहाँ पे
ये.
ये जो आपका
अच्छा.
zero
हाँ.
जो field है ना. Yeah.
हाँ, so this is the error, like ये तो ठीक है. Yeah. नहीं चल रहा है. नहीं, वार्निंग नहीं है. Let's see if I'm getting warning. Look up customer order ID. Are you getting any warning here?
And when you do the unwrap, one of the bad examples,
Yeah.
it panics and crashes over there.
Bad example, it will crash, yes.
But if you ignore the one warning that the field 0 is not being used, then alt has passed.
Okay, 1 second.
So yeah, you can just revert to good bad MP instead of doing the unwrap .0.
Column. Column name. Column. Sorry. Column name is not actually getting used because up till now here we are still not extracting it anyway. The whole struct, the complete struct is getting printed. Let's try to use it actually right now. Say So I use this pattern actually itself, like if good dot is error, println error, and then I write, I can. You can do that, you can do that. But normally this is the pattern that I use, like, because down the line, whatever that I am writing, I am safe that I have handled the error, then I can actually do it. So, yeah, yeah, yeah. So yeah, now it's not being used. Huh. So yeah, so here what we, the earlier the error that was being sent to us was as raised by that 0 was never getting used. When we are doing println, so these are debugs, right? So they are not considered to be the used actually. The printlns are for debugging purposes and all. So when you actually start using it, then it will, the error goes away. So in println not considered as the usage actually in debug mode. कितना टाइम बचा है? अच्छा. Okay, so I think we are running short on time. Okay, okay. So if everyone have actually done this part of using this customer ID and defining their own type and using new good, can we confirm that are we using the new type, have defined new type and using it? Okay, so so what we have learned from new types here, like we have defined our own type here. We have defined our new function first time for that particular struct, which is again a very important for us in terms of defining what function that it can run. Constructor is like new function, it's not a key type, but it's a very good pattern to use to initialize a particular struct itself, and it returns a column and then you can define it. We'll go to the transform part where we are actually like want to ensure that particular functions can only work when a struct contains certain type of object. For example, in pandas, everyone use pandas, right? So if it's a series of strings and then you call dot sum on it, Python is not stopping to do that. If you are actually having any series of any other type and you're using other type, it crashes on you. But here itself what we'll be seeing is like if in a data frame, we'll define a small data frame itself which contains name and a vector, and when you call say dot sum and it contains, if it contains integer, it will fail on you on compile time. So it says that dot sum is not applicable here. And if you say if it contains a string of array itself, then you say uppercase, then it will be actually be showing that the uppercase is applicable to it. So that way you know, for that matter, if I am passing a certain type or a user is using a data frame of say integer, it will actually be only can call dot sum, dot average, and that like that instead of making any mistake. So this is something that we can enforce to our users itself. That, and we are using this particular pattern day in day out of phantom data, where we define a phantom data that if a type is of particular integer, float, anything, and certain functions can only be used. So that way we are ensuring that the whosoever is using it will not make a mistake of calling a different function on it. So Okay, so the phantom data is more of like a advanced marker. It doesn't cost you anything. Like when you define a phantom data, we'll add a phantom data here. So, okay, and I'll define the T. So it's this is very similar to the Java where we define generic types. Like the column can actually can accept any other types also, float, integer, string, or your custom struct types. And this is just a marker. That doesn't cost you anything. Whatever that you define here, string, the phantom data keeps the track of the compilers knows that this is a column of string type and certain functions can only be called upon it. So this is only a hint to the compiler itself that these functions are only applicable of certain types itself. So let's implement this. Huh? Certain functions, like as in like I want to define last time in our exercise itself we define a function called new, right? These are the function defined for column name itself. Now this is very similar to the column is very similar to series in pandas, okay, because it contains name and data. Now based on what data it might contain, we want to restrict what kind of function it can be called. Now if it contains string, okay, so I want only uppercases, or for that matter only the string operations can be done on the column type. And if it contains integer, I want to support average, sum, or other types which are very specific to integer types itself. So these are the functions that I am calling out: sum, average, concat, uppercase. These are the functions that I am defining. Will be applicable, and again in those functions we are defining what function can be applied to when certain generic type is passed. In Java, suppose if you define a generic type and you define function, they are applicable to all of them, whatever data generic type that you might pass. So you don't have a way to check it at compile time that these functions can only be applied when I pass string or integer, or you need to mention it, like, or you need to check whether if it is a string then these are applicable. So these are very expensive to achieve in other languages, like you need to do reflection and all to check whether these are being used. Huh. No, T you can pass anything, but you are defining if T is integer, then what function can be used. Yeah. Acha. Yeah. So I don't know like much of the C++, so maybe like I think these are all languages we can achieve any way or other for that matter. But this is a first class construct in Rust itself. So you get from the compile time itself that you can see that we'll see that how a sum is cannot be called on the string type. So just add this type phantom data and make it generic, this column itself. नहीं टी तो रहेगा. So yeah. Okay, so I'm just now copying things from the solution itself. So we have implemented a new generic type and we have defined a phantom data. Now it recognizes that the type T is string. So whenever, yeah, अच्छा, रुको रुको मैं करता हूँ, ये हट कैसे गई? So it gives a hint to the compiler itself that the type is of string. Now we'll define the sum on it actually. Let's define the sum part of it. Okay, so I have, for the sake of time, I have defined different functions for this particular column type, where I have defined an uppercase, which is running on only a string column. This is the generic type. And I have defined the cast to float, which is only again for float type. So if I see here that amount.sum, because it's of a column integer type, I'm not getting an the recommendation or to call the uppercase. It's only showing me the sum is actually can be only be implemented. Where we started, like, though it's of column type only and we have defined it's of empty column, generic column is column, but I'm not making a mistake of calling something else, say for example uppercase. So any other language wouldn't have actually given me this at compile time itself. So we have defined what functions or what type. Based on the type, it determines like what function it can be called. So think about it as a data frame, and you have initialized it, and then you are calling some, and then it might fail upon you later. Or for that matter, in pandas, you call some on string, it actually concatenates all the values and returns you it. So that way you can be sure that if a frame or any particular type is initialized with a generic type, you can call only a certain types of function onto it without making any mistake. So this is the sum, and again same for the float. So all these won't be actually be compiling. So this is like what you can actually achieve by defining your own types and phantom data here, defining the phantom data, which gives the hints to the compiler itself that certain function can only be called for you. So it's a more of an encouragement when you are defining constructs and all, you want to ensure that only certain function can be called, you can always use the phantom data. So please, yeah, so let's complete this part with respect to phantom data. This is actually a very advanced stage in like in defining generics and all. If we are able to complete this, then I'm sure that you might be able to appreciate the part. I think let's complete this. And with respect to the next exercise, we'll walk through it. But this is the last exercise that you might we can actually complete. Yeah. Okay, I have created a generic trait. So the syntax for actually implementing is like I have defined on when you again creating a framework or something like that, you define your base types. Like in Java, you define your own object. Every object is being that you create is inheritor of object. But sometimes that you want to create your own object, you create, say like I'm starting a hasgeek numeric trait, and I want to make it implement all the traits of hasgeek should come into my new construct. So this is a way to actually define that whatever that I might implement in numeric will actually be implemented for int call also. So I can define functions, empty functions here like add, that's it. So this is a very interface, very similar to Java interface, and I need to implement these implementations down below. So this is how you can actually define interfaces and enforce anyone who is actually using these constructs to define those functions itself, and they have to be mentioned. I think this is the same interface, like you also get a compile time exception in Java also, but here you are actually getting those encapsulation and all the benefits of the object-oriented programming. So I think we should be able to see these exceptions. If we are able to see these exceptions, that on amount I am unable to apply uppercase, on name I am unable to apply cast to float, we have achieved what we want to achieve in Rust. Let's just complete this part. Yes. Phantom data is more of a like an indication that this certain type can might be included in this. So whatever the cases or the applications are that at compile time I want to um, mention that this can hold this only data if I have defined a integer type. So more of restricting the you have 100 functions, but you want to divide them into 10, 10, 10 into different types. Then that's something like we are coming from like we included this part only because we are using this like very similar in our framework like pandas. We want to create very similar construct like pandas but in Rust, and that's how we are able to enforce that we are not making mistake. So that was the main reason of like in data engineering we use this pattern a lot because in data engineering you might not know what type of data you might be pulling. With SQLs it's very definite like you because they are very well defined in your DBs and all. But say suppose you are reading a CSV, then you don't know what type it might contain because everything is contained as string. But we want to enforce that if we are reading a string or a column is integer type, then what operation can it be done on it? There are multiple ways to do it. Phantom data is an zero string or zero memory. You can define it via array also. Like there are certain ways to, but phantom data automatically detects that what type of data is like what we defined here. So when you define T here, like whatever that T might be, phantom data like determines the same. It gives a hint that same might be used as type. The type will be of this particular thing. So you can, there are multiple ways to achieve this thing, but phantom data is like allows you to automatically detect what type it is.
Pandas, right? We are making some of n number of one of whatever we are randomly we are making some other string. So okay, it will do the error, right? But for this case, like in pandas also they will explicitly define okay, or if you want to make a sum, you need to use this particular column which is already using allocated integer type. Then only you can pass the sum. Right? So we are explicitly defining the things in Python as well. Making the sum of this
You need to make those checks.
before
Yeah,
making the sum.
yeah, in Python itself. Yeah, but here you don't need to do. Big, yeah.
Here we are just defining the types and the form. In the multiple pandas it will happen and you will never find out. If there is a list of strings or something or all this stuff, to be inspected here it was related.
If you define a particular type, say to pandas I am passing a series. Okay, this series could be of integer, this series could be of string and anything, and you apply a sum. It will work on both cases, but it should work only on integer. And how will you get to know? When you actually see the data. This is where you actually enforcing everyone to define the sum can only be applied to integer, because in we are all coming from non-typed Python based and all. We know that the data that might be coming up, we don't know their type itself. In Rust itself, when you are passing it, that type will also be defined, and you have a tight security at compile time that when I apply some certain functions, I know the type also already that is coming in, that is of integer or string, and I will be only applying these functions itself. So it's making you tighter at the right time itself. Yes, yes, yes. Yeah, that is the intention. That is a strong type, extremely strong type. Yeah. Yeah, yeah. Yeah, so that's what we were saying, that in Rust, whenever you're passing, you will always be knowing what type it is, because the whole Rust ecosystem is that whatever that comes in, you have to define it. So it's not like something like it's a generic, I don't know okay, what type of it is. When you're entering the Rust ecosystem, you have to define everything. Okay. Do we need any help? Huh? Yeah. 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 Huh. Huh. Hmm. 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 So before entering or before using the Rust ecosystem itself, I am mandating on you कि you define those column types through me, right? So absolutely, absolutely. So there is a part where before entering an ecosystem, I need to define what types are it is. Only then I can use sum, average, or any machine learning algorithm on it, right? So it's onus on me. If I want to use Rust, power of Rust itself, I need to define those initially itself. I cannot push down to the, please. Yeah. Hmm. Hmm.
Suppose 10 more columns going to add, and
Yeah.
remain 10. And there is a, then again you need to make a code change to reduce those parts.
Like it's not that as simple as like we need to keep adding more, like for that matter the code change doesn't needs to be do that, like when we are uploading CSV, there is no hard coding that first column has to be defined like this and that. We dynamically define the determine the types, and then we pass it to down the line processing engine. So before processing, I need to determine the types and then pass it. Processing cannot work on the generic types or the types that I might not know. So you understand the part, like processing is statically typed. Yeah.
One part is computation,
Huh.
one part is validation. So it means currently, like in Python ecosystem, we take the data, we compute it. Suppose, okay, we know this data is coming, and runtime we will check everything, and it will go pass. So here is the one layer you are putting here, so checking like if
Yes.
100 columns,
Yes.
110 columns is coming, then again you are validating all the columns
Yeah.
one by one, and then
Yeah.
you go
Yeah.
for computing.
Yeah. Like I think the last type was actually regarding the same also. Like we want to mention this particular type of like the flow, the pipelining effect itself. So if I actually show this part, I'll show the solution itself. So we are using a query builder. Now from query builder, when we initialize a query builder, we get a no select. There is no select in it. But when we add table to it, it becomes complete. And on complete only then I can call a where clause. So this is the pipelining effect that we are enabling you. Now no one can actually call a where clause before it. Right? In all the builder patterns of Java, it actually doesn't, you can apply the builder clause like anything before, anything after for that matter. So in the same thing that you have defined, I need to do a validation, I need to define the types, only then I can do a processing and anything else. But other languages doesn't enforce me to do it. You have, like, you can pass me like anything, I'll figure it out later on. But that reduces the amount of effort down the line itself, because I know, for that matter, this is a parsed content. This is a validated content. I don't need to do again and again those checks. Like it could be a string, it could be an integer. I don't need to do it again and again. I know, for that matter, that it has come into this part. Up till now, I just need to do some. Yes. So that's the enforcement that is happening. It looks like a so much tedious task to actually, like, I have to define it everything, and that's the beauty of the Rust, that and more determinism that is actually coming into the picture, that we need to define everything before we actually do it. So that's how it gives you confidence that either running on a desktop, either running on a server, if it compiles, it's done. So, so the last part was mostly about building SQL builders. We used the same phantom data that we defined earlier itself in transforms, and we wanted to show that because we are also building a SQL in our product itself, and we are setting up, like, if a new query builder, it returns a no select, then you add a select, then you add a where clause, then it becomes a complete. If I actually apply, I won't get only from is something that I'm getting. I'm not getting select before the complete itself. So that is the empowerment or the easyability of your usage of SDK. So yeah. Yeah.
So in my case, on like a daily hour or like a daily basis, number in column numbers to change in my CSV. So I cannot use RSJ, right?
Yeah.
Because every time I need to make a code change to support all.
No, there are ways to handle that. It's not something like that you need to do a code change, generic types and all everything. So there are ways to solve that. If you actually explain that what's the use case, we might be able to help you very specifically, that you don't need to write every time a new column add and you need to change the code. So we can work on that. We can connect later on to this. But yeah, so I think I'm passed to like, yeah. So the question is, what does a query that joins two tables on a key looks like? So for example, I want to define join only on complete tables. So when the query has been completed, I don't need to define toSQL. Like I want to enforce, you need to do join before toSQL. Okay, so here itself I can define that instead of complete, I can define joined table. It accepts only join table, and only then I can call .toSQL. Otherwise, I won't be able to call .toSQL. So that's how it looks like. You need to you have enforced it to actually use it at compile time. Okay.
And even if you like comment this from select, you won't be able to reach to SQL.
Yeah. Cool. So I haven't spoken so much since last 1 week altogether, but
SQL is needed. It can only be reached when select is true.
yes, yeah.
Select is valid.
Yeah. So the intention of this workshop was not to actually teach you a syntax, but the power of what Rust can enable you or what it can enforce. If you are building something, an SDK or a system programming, or you are giving a binary to someone else, and he has to enforce it. You have to enforce to your customer itself, they don't make a mistake. And that's how it enables the successibility of your product itself, that customers are not making mistake to actually use it. So Rust is enabling that. And post Claude Code word or the Codex word, I think syntax is very very huge. Like in Go, you have only 36, I think, constructs that you can define a whole language. In Rust, there are more than 500, but now we don't need to actually worry about that. We should be focusing on more on, like, if you want to handle billions of rows or billions of data without GC, you want to enforce that people are not making mistake at the compile time or at the runtime, sorry. So then it's a good pick. Rust is a good pick. You don't need to worry about learning the whole language in the cloud code word and all. You just start building. The idea was to actually showcase like how we have built OrcaSheets, which is running like on desktop. The whole code binary is actually getting compiled, and we are not worrying about what might fail. So we hope that we have given a small encouragement to actually start using Rust, and we can be reached out very easily. Just give us a holler at hello@orcasheets.io. We are building all the other Rust stuff also, like CLIs, binaries. Some of our, the good part is like OrcaSheet completely, if you actually use it, it's a 50 MB binary. It can run on Raspberry Pi also, on a 250 MB binary. It's a 250 MB RAM itself. So that's the power of it. And more you will see that people are using local first, like your Claw, OpenClaws, and for that matter, everyone is actually building their own desktop version. Like Claude has desktop version, Codex have a desktop version. They are bringing CLIs, Gemini CLI. Most of them you will see that they are migrating to Rust. So because of the things that we have discussed over here, that makes less usage on your machine. When I was running, I think OrcaSheet is still running. It has access to more than 100 million rows, but it's not impacting me. Yeah, go ahead. Yeah, that's a pain point. I would say that, but OrcaSheets we built to almost 4 different locations, but now tooling is very strong, extremely strong. You just need to mention the target. So for example, here I can define all the targets that I want to compile it to. So ID is very enabling you to define, like I can define, it's currently Apple Darwin. I can compile it to GNU, MVCC, Windows and all. So, and there is a thing called universal binary. You can, like for example, in Mac OS, we are giving a universal binary, which works on Intel also, which works on Mac also. Okay. So, but tooling is very strong right now. Like I wouldn't say that 5 years back it was that strong, but now I can just click and get the output of what can be done. So, and a lot of people are building now pure Rust binaries. What does that mean is that you don't depend upon the different platforms. Pure Rust binary mean that it can compile to all the different platforms without any your intervention. Because say for example, I'm using say PyTorch. PyTorch is compiled in C or C++ for that matter. It's being compiled for different platforms also. If I'm using PyTorch in Rust, and I know that PyTorch is not pure Rust, then I need to make so changes. Sometimes it might not be available for ARM. But when you see a particular library saying that it's pure Rust, then it means you don't need to do anything. You just need to click on different types. See, like I think just now compiled for Windows itself. So if you are looking like targeting to build something, just check it out, like whether there are pure Rust libraries or not, and if they are, you're good to go. Yeah. No, absolutely. There is a. Yeah. So just to give an example, I think we are sitting in E6 data. They are using DataFusion a lot, that I know. DataFusion complete binary. It's an LLVM of building data pipelines. Like you can build your own engines in DataFusion itself. The whole DataFusion library is 30 MB. Okay, And a similar stuff, if you say pandas, it's I think 600 MBs. And more larger Python based like polars and all, they are like much larger than that.
Even the machine learning algorithms that
Yeah, so in OrcaSheet you can run machine learning algorithms. We are using Burn as a library. We implemented logistical regression, it's a 4 MB binary. That's it. We are able to ship machine learning binaries on the air itself without impacting the others itself. So that is the efficiency of the compiler itself. So we have built more on DataFusion. So DataFusion is kind of a, say, again, that what I said, LLVM, like it's a more of a language to build more engines itself. So we are using DataFusion. Cool. I think almost done. So any more question, I'll be happy to answer. Okay. So, yeah, done. Yeah.
I should.
Yeah. And done.